Hello everyone, welcome back to the channel. In this video, we are going to implement a priority queue using array. We are going to take help of a normal integer array, and based on the priority, we are going to do insertion or removal. Let's see that in action. We are going to take one integer array. Let's call it items. Let's take one more variable as count to count the how many elements are there in our queue, and let's start with the implementation itself. Private, okay, public void in queue and item. We want to check if our queue is already full or not. How we can do that? Using the count variable. Count is equal to items dot length throw new illegal state exception. Queue is full. Let's extract this condition is full. Right, now if your queue is not full, what do you want to do? If your queue is not full, you want to take the index. So if I show you the priority queue from Java, right, it works something like this. So priority queue of integer queue is equal to new priority queue. So in this queue, if I try to add, let's say 10 and then 20, right? Let's add 30 as well. So if in this one, if I'm trying to remove, right, while queue dot is not empty, what you do? You remove elements. Queue dot remove. Now if we run this has nothing to do with our implementation that we are doing. This is the priority queue from Java, right? So what are we getting here? We are getting 10, 20 and 30. First it is removing 10, then 20 and then 30. Now whichever number is less, right, that it is trying to remove first. Now what I mean by that, let me enter an element here, let's say 7, right? Now if you try to remove, this is the priority queue from Java only, right? So first you see what it did. So first it removed 7 from the queue, then it removed 10, then 20 and then 30, right? But we have added the 7 as a third element in the queue. So that's what I'm trying to tell you. Whichever number is less, right, that number has the top priority to get added or removed. So that's what you're seeing here. That's why 7 is getting removed first, then 10, then 20 and so on. So this is the implementation from Java side. Now when we are implementing, right, we want to implement in a similar way. We want to make sure in your queue the elements that you are trying to add is added at the correct location, so that when you are trying to remove, it is removed correctly as well. How do we do that? Let me remove this Java implementation, because we are implementing our own priority queue for index. We want to reuse this variable itself. Index is equal to count minus 1, because count takes one more value every time we add some value to the queue. My index is greater or equal to 0, do index minus minus. And what we want to check inside the loop, if the items, so if the items at that particular index is greater than the item that we are trying to add right now, right? If the items at this particular index is greater than the item that we are trying to add, then what you do, you shift it. Items at this particular index, right, will be shifted to one index ahead, like one counter ahead, index plus 1. Items of index, that's it. So that when it reaches the correct index side, you will find that particular location in the queue and you will place it there. How you will do that? What if the element at this particular index, it is not greater than the item? Then you exit the loop there itself. Else break. Now that your index, now you are able to find the correct index for this, right? What do you want to do? You want to set that index plus 1 to this item, right? Now let's write the dequeue method as well. Public int dequeue. What we are doing here, return items minus count, and that's it. I think we are good here. Let me extract this so that we can get the correct index in the priority queue. Get index for the item. So it is returning the index. Okay, we are incrementing it here. If you are getting the correct index, why do we need to increment it here? Let's shift this to here itself, plus 1. Perfect. I think we haven't initialized our items array, so let's create a constructor for that. Int size this dot items is equal to new int of this particular size. Okay, perfect. Now we have our enqueue method, that is add method. We have our dequeue method. There is a chance that you are trying to remove the elements from the queue, but your queue is already empty. In that case, what you want to do, you want to check that with the if condition. If your count is equal to 0, you're supposed to throw new illegal state exception, queue is empty, right? I think we can extract this condition as well, is empty. Perfect. Now let's see the demo of these methods to see if the implementation that we have done for the priority queue, right, is correct or not. Alpha q is equal to new alpha q. Let's give it a size of 3 for now. We want to add the elements to the queue. Let's add 3, 10, 20, 30. And what we can do, we can have a toString method as well, so that we are able to print all the items in our array. Let's do that as well. toString arrays dot toString items. Now if you're trying to print it, we are supposed to get 10, 20, 30, right? We're getting 30. So we got this particular 30, 0, 0 because we haven't incremented our count variable. And we are enqueuing, basically adding the elements in our queue. Let's do that, count plus plus. Now when we run this again, we are supposed to get 10, 20, 30. We are getting 10, 20, 30. So you see, those mistakes are really common. We're supposed to keep an eye on that. So we are getting 10, 20, 30, that is perfectly fine. Now what we can do, we can check our dequeue method implementation as well. So s out q dot tq. Let's see what we have right now. We are supposed to get so you see we got 30, right? In our implementation, what we have taken, we are considering the highest number as the highest priority, right? So that is why you got 30 when you try to remove the elements. Okay, now for this one I can show you one more thing. So when you're trying to print this array again, what you are getting, you got 10, 20, 30. You have removed this 30 as the highest priority, but you're still getting all the elements. You're supposed to get 10, 20 only, not 30, because when you are trying to remove, right, when we have called this deq method, we haven't set the element to 0. So if you are setting the element to 0, then you will get the 10, 20 only, not just 30. Let's see if that is correct. Yeah, that is correct. But I think you are getting a warning here from Sonar. It is telling us that this is not the right way to do it, although the logic is correct, but still it can be done in a better way. So let's do that also. Let's assign this into a variable called removed item. Instead of decrementing it, this is fine. I think that is not a problem. We can set it to 0 in the next line. Okay, this is already decremented. We are setting it to 0 in the next line, and then what we are supposed to do, we are supposed to return this removed item. Perfect. Now you are not supposed to get any warning from the code, and you're not getting it. So now, as per Sonar, our code is written properly. You can remove this as well. Yeah, you have assigned the value that you are removing. You have set that particular index value to 0, and then you remove the item. Now if we run it, we are supposed to get the same output because we just refactored our code, and we are getting it. So that's all. That's just a simple basic implementation of a priority queue, where we are considering the highest number is the highest priority. Okay, so we have added the element. I think yeah, we have added the element. We found its correct index to place that particular item, and we placed it, right? So while adding itself, you're adding your particular item at the correct index, and while removing, what you're doing, you're taking it from the end, because we have already considered that highest number as the highest priority, so that number should get removed. So yeah, this is just a basic simple logical implementation of the priority queue. I think that's all we have as a concept for the queue and priority queue. So it creates a good foundation for you to understand how queue, this FIFO, first in first out, this order works, how those front and rear pointers move. So I think this is good enough for the understanding of the queue and priority queue. Just practice it once. If you have any doubts, feel free to comment on the video itself. And that's it. And see you in the next video. Meanwhile, may the source be with you.